Hello and welcome. The topic of our discussion is amines, classification, and nomenclature. Amines. The amine group is being attached to carbon atom. As an example, I'm going to write down R, which is any carbon chain, CH3, CH3, CH2, and so on. And now the amine part is single bond, nitrogen. Nitrogen, as we know, has three bonds to make it neutral. So we have one for R, or one here, and one in the bottom. You can put it on top. The position of it doesn't make any difference. And for basic amine group, we should just get hydrogen here, and also to make it stable, we put two electrons on top, one lone pair. For the naming, amines have amine ending. The simplest amine is methylamine. So if you take a look at this formula on the side, you can see that it has amine group. That's why it's part of a name. It ends as amine. And CH3, it's one carbon, just like substituent, methyl, and that's why we get methylamine. There are there are actually a variety of ways to name amines. So you can see the first one is methylamine, what we discussed earlier. Second one is methanamine. The reason being because now we look at meth as being parent chain, one carbon meth, AN single bonds, and amine is just because of NH2 group. And also we can put amine group in front. So again, meth is a parent chain, AN single bonds, E hydrocarbons, and amino is a substituent to this methane. So you can see there are a variety of ways of naming that structure. Amine structural view. So here, the amine is derived from ammonia, NH3, and here we have nitrogen, hydrogen, and three more hydrogens in total. Now the difference between ammonia and amine is that one hydrogen, this one, has been replaced by alkyl group. Now amine, that's why we call it amine derivative of ammonia. The reason being is that it's not just this hydrogen which could be replaced, but any one of this, or any one or all of those hydrogens could be replaced as well. That's why same as we have R over here, such as CH3, you can have another CH3 instead of this hydrogen, and CH2, CH3 instead of this hydrogen. You can put phenyl groups, which is a benzene ring, etc. So that just means that you can take ammonia atom, ammonia molecule with three hydrogens, and each of those hydrogens could be replaced by R group. Here is an example. So you have nitrogen. You got two hydrogens which still could be replaced by any carbon chain, but as part of the substituent to the nitrogen, you get all this huge group. Now take a look at the next molecule. It's NH2 on this end and NH2 on that end. You can have multiple amines in the same structure, but you can see that it's not NH3 but NH2, and NH2 and everything else, meaning this alkyl group, including NH2, is part of this attachment of that substituent. Same goes here. You have NH2, and third hydrogen has been replaced by all this long group. Classification. Amines are classified as primary, secondary, or tertiary, which is based on the number of organic groups attached to the nitrogen atom. Let's look into details. Primary amine. It has one organic group which is directly attached to the nitrogen atom. Now, we are looking at this nitrogen over here. This nitrogen has only single carbon chain, which is there. This hydrogen and this hydrogen doesn't have any carbons. That's why this is a primary, because it only has one alkyl group connected to the nitrogen. Secondary amine, we have two organic groups directly attached to the nitrogen atom. So on this example, you have nitrogen over here, and it has one alkyl group, and it has second alkyl group. And this hydrogen doesn't count. That what makes this specific molecule a secondary secondary structure, secondary amine. Finally, we have this nitrogen has 3 carbon chains. So we got one here. This would be primary if it would be alone, but also we got second over here, and there is a third one over there. And let's talk about naming. So notice that all of those molecules got amine as part of its name because they all have nitrogen in it. But now we are going to refer to substituents just like alkyl groups. So for example, this molecule, we only got ethyl, 2 carbons, ethyl. That's why it's ethylamine. The hydrogens, they're just going to be part of amine. Now, for this kind of molecule, we got ethyl on the left, ethyl on the right. So there are 2 ethyls. We're not going to name them ethylamine, but we are going to refer to them as di, meaning 2. So that's why it's diethylamine. And finally, very similar logic, we got nitrogen, we got ethyl, second one, third one. Total of 3 ethyls. That's why it's triethylamine as a single word. Practice problem 1. We need to write names and specify amine classification for each of molecules, A through D. So the first molecule is going to be called isopropyl propylamine. And again, this is just one of the possibilities because we know there are at least 2 other ways of naming this compound. Now, first of all, we know this is the nitrogen, which makes this group amine. Also, we got 2 substituents. We got propyl, and we got this substituent over here, which we refer to as isopropyl. That's a common name. Easy way to remember this is, first of all, it's a propyl, so it has 1, 2, 3 carbons. Also, from this carbon, we have equal number of carbons as connections. So we got 1 carbon on top and 1 carbon on the side. So since we got equal number of carbons from one center, this is why we refer to it as iso, which is equal. That's why altogether it's isopropyl. And now we just need to put those names together alphabetically. So I comes in first, P comes in second. That's why it's isopropyl as a substituent, propyl, and amine. Now we understand it's a secondary amine because this nitrogen has 2 substituents attached. So we got 1 organic substituent here and second substituent there. This nitrogen is not occupied by organic group. That's why this is secondary. Next structure is tripropylamine. Now, we understand it's amine because it has nitrogen. Now, tripropyl. So now, if you take a look at those parentheses, it means that this nitrogen has something attached to it. So now, in parentheses, you got 3 carbon chain, and it's being repeated 3 times, and with a connection to the nitrogen. So that means that this nitrogen has 3 carbon chain attached to it, and there are 3 of them total. That's why it's propyl, and another propyl. So altogether, it's tripropylamine. You have to use tri because there are 3 propyls, and you don't want to use it separately. Instead of saying propyl, is just tripropylamine. Next structure. It's methyl. Oh, and by the way, this was the tertiary structure. The reason being is because it got 1 substituent, second, and third. So all of those hydrogens being replaced by organic substances, organic groups. That's why it's a tertiary amine. Next one is methylphenylamine. So again, this one has nitrogen. Now, over here you see methyl, but sometimes you can actually see it as CH3 group. So whether it's you see it like this, like methyl, sometimes if it's ethyl, it would say ETH or like ET, and CH3 is for methyl. And phenyl could be written in multiple ways. It could be written like this, the way you see it now. Also, it could be written as 6 carbon ring with a circle, or alternating double bond, or sometimes it's just written as C6H5. The reason being because it's a 6-membered ring, and each carbon, except for connection, has hydrogen. So there should be 5 in total. That's why it's C6H5, and we refer to it as a phenyl. So there are 2 main groups, methyl and phenyl. Put it alphabetically, M followed by P and amine in the end. So you get methylphenylamine. And notice that it's a secondary amine because it has 2 organic groups. One is phenyl, second one is methyl. Finally, it's dimethylphenylamine. So over here you have methyl, and this is also methyl. That's why it's dimethyl. And this substituent is phenyl, and that's why there is a P followed after dimethyl in alphabetical order, and amine because you have nitrogen in the center. Dimethylphenylamine, and we understand it's a tertiary compound, and the reason why it's tertiary because we got 3 organic substituents which are replacing main nitrogen in the center. Practice problem 2. We need to write bond line formulas and specify amine classification. Let's begin with propylamine. So propylamine is simple because first of all we got NH2 group. So this is amine. So this is just amine, and we got 3 carbon chain, which is just a simple propyl. So altogether it's propylamine. It's a primary amine because there are 2 hydrogens left over, and there is only one organic group which is connected to nitrogen. This is what it makes it primary. Next one is ethyl isopropyl methylamine. Okay, so first of all it's amine because we got nitrogen in the center. Now there are 3 substituents. First of all, ethyl just means 2 carbons, 2 carbon chain. Isopropyl, this is what we discussed before. It's a common name for specific 3 carbon substituent where nitrogen is connected to secondary carbon. So this is what makes it isopropyl. Okay, and finally, there is another. Well, there is another group which is methyl. So that's why it's ethyl. We got it on the left. Isopropyl. We got it over here on the right, and it's methyl because it's in the bottom, and amine because it's a nitrogen. Also, this is a tertiary structure, tertiary amine. The reason being is because nitrogen has 3 organic groups which replaced hydrogen atoms. Finally, trimethylamine. So this just means that, first of all, it's amine, and we got methyl group, second methyl group, and third methyl group. Altogether, it makes it 3-methylamine. So there are 3 methyl groups. Also notice we could write this in this kind of form. It just means nitrogen has 3 methyls connected to it. This concludes our lesson. Please let me know if you have any questions in the comments below. And I'll see you in the next tutorial. Thank you for watching.